How do you build safely in a world where everything you need to know is missing? When the United States and the Soviet Union were competing to get the first man on the moon, they had an issue, a major one. They didn't know if the moon dust could handle the weight of a person, let alone a multi-ton rocket. To solve this, scientists sent rovers, probes, landers on this completely foreign world just to understand a little bit of how the soil works. That data helped scientists understand how the soil worked and helped engineers design rockets able to land to very certain specifications. But these were temporary solutions. At most, humans only stayed on the surface for about a few days maximum. Now with the new space race focused on long-term presence or even settlement on other worlds, how do we build the infrastructure? Short answer is, they're still working on it. Because before engineers can even decide to build something, they need data. Yep, data. And lots of it too.
Biggest concern that I would have would be just not knowing what's underground. I mean, that's the biggest concern on Earth too, but we have like some things that we know we're fighting against on another planet. You might not know as much. And so that's why I would want to do more testing, right? We tend to rely in geotechnical engineering, we tend to rely on local knowledge that's been accumulated over time with people practicing. If you're working on a planet that nobody else has built on before, you don't have any of that. Just because it would be so new, I imagine that there would be a lot of collaboration between different disciplines, the instrumentation and the testing and the sampling that they do, that a lot of different disciplines want. There's in situ testing where you're trying to evaluate the engineering properties of soil in the ground, but then we also do a lot of sample extraction and then lab testing. There are adjustments that might need to be made, but for the most part, for soils testing, I think that you would be able to use the same tests.
Okay, we get it. On Earth, data is really needed, especially in space. So what are the obstacles in space right now? Well, the problem is, what might be solid might not be up in space.
Exploring, building models for planetary science with these different gravitational environments and atmospheric conditions, and then going and doing field exploration to see if those models make sense. So if you're building on sand, you would want to know how deep it is, how dense it is, how long would it take for that sand to get blown away or more sand to get deposited. We rely a lot on vegetation to prevent erosion. There's no vegetation on Mars that I know of. Like the assumptions that we have about how much erosion there might be in a given time period are likely going to be completely off of what there would actually be. What's the fracture network in the rock on Mars? All rocks have fractures in them. How widely are they spaced? What's their area? What's their volume? All those things matter.
There is a very cool way to look at this. NASA's Opportunity rover once got stuck in the sand on Mars. The clip isn't looping. Time is passing. You can tell because the shadow shifts and the rover powers down at night and turns back on during the day. The key detail is in the dirt. It never returns to its original state. The rover is literally moving an inch or two at a time, slowly pushing because it's stuck. That's how volatile the dirt is on other worlds. It's a reminder that even our best technology can still struggle with something as simple as soil. All right, awesome. Assuming we can understand the soil and start to build, how do we build?
I mean, not having access to concrete is a pretty big limitation.
Well, shoot. If we can't import concrete, does that mean we're cooked? What do we do? Well, if we can't import building materials from Earth, then we could just get it ourselves. We can try building using the local soil. Composites are materials made by combining different materials to create something stronger and lighter than each part alone. They are used off-world because they need fewer resources like water, can use local materials, and are easier to produce in space than concrete.
So yeah, I mean, I imagine that there would need to be new kinds of composite materials. So yeah, I could totally imagine the kinds of materials that are being used or construction techniques being something that nobody has thought of before, either because it would be too expensive on Earth. So yeah, that would be cool.
And then there's disaster. Mars has Markquakes, and the moon has thermal quakes. They aren't as dangerous as here on Earth, but even small shaking can be detrimental.
I would want to know, like, okay, Mars, if all the Mars quakes that we have observed have been small, how confident are we that that's like the total variety that you would expect to see, so to know whether or not there would be a larger one at another time. At the same time, a very small magnitude earthquake can be more damaging than a very large magnitude earthquake, depending on how close you are to it and how deep it is. Geotechnical engineers work with seismologists a lot, right? They do the modeling to predict earthquakes. We tend to take their work product as input to our models, predict how the soil will behave or surface rock, and then we pass that information on to a structural engineer. So we're kind of in a chain of information.
But it isn't just these world quakes that are dangerous. Other hazards like dust storms, landslides, and even meteorite impacts, which is a real possibility.
Hey, I've never had to consider meteorite strikes in design, so that's interesting. But yeah, I mean, on the moon where there's no atmosphere, or on Mars where there's a different atmosphere, I imagine that there may even be like categories of natural hazard that I haven't had to consider and haven't had to think of, like the meteorites. That's a good example. As an engineer, it raises a concern level. The more we understand something, the more, even if it's very dangerous, the more comfortable we are with it, because we may know how to deal with it, or we may know to avoid it. The unknowns are hard to deal with and fairly concerning. So the more rapidly you can collect data and reduce that uncertainty, the better.
It isn't engineering without also taking into consideration ethics. Even on Earth, where engineers have decades of data, mistakes still happen. Bridges collapse. Systems don't behave the way we expect them to. Now take all of that data that the engineers on Earth have and remove almost all of it. That's the reality engineers have to face in space. On Earth, the worst outcome of a small mistake might be a delayed project or a very unhappy landowner. In space, a small mistake can be a fatal one. And these aren't temporary shelters. They must constantly provide oxygen, water, and food. They must protect against radiation, micrometeorites, pressure loss, and so much more. And failure of any one system can put lives at stake. Designing a spacecraft is already one of the hardest engineering challenges humans have ever solved. Designing a permanent home in space is even harder. That's why ethics isn't optional in space engineering. And engineers are forced to ask a difficult question. How much uncertainty is acceptable before lives are put at stake?
We always are designing things without knowing exactly how safe they are. We use our best judgment and we use as much information as we have to make informed decisions, and we try to stay within bounds that have been successful historically. The difference in like an unknown environment is that you don't know as much where those bounds are. There's a lot of different ways to try to deal with that, running multiple scenarios and checking like, okay, well, this is the way that what I think the situation is. What if I'm wrong about this? What's the range of like physical possibility? Evaluate how that change would impact your design. You would try to identify those things that have the biggest impact on your outcome. At least in my view, ethics are the principles that inform your decision-making process. People are not super comfortable with the idea of quantifying like the value of human life, but we do. There's a thing called FN curves that, even though obviously we prefer not to kill anybody, there are like acceptable levels of risk. In space exploration, the frequency of accidents might be much higher. In a lot of ways, like, it seems kind of callous to talk about it in those terms, but I would apply like the same principles and just have to think through them more carefully, knowing that I'm working in a different environment. I like the same principles and just have to think through them more carefully, knowing that I'm working in a different environment. Yeah.
So what kind of engineers do we need for this future? We don't need just builders, but problem solvers who are comfortable saying, we don't know yet. There aren't many opportunities to build in space yet, but getting there requires a lot of work.
Everything is built on something. You need to have a foundation, a contact between the built environment and the natural environment. So like the International Space Station is not currently sitting on anything, but in order for it to get launched, right, like all the stuff that was built and launched, you can imagine that it would be really problematic if like the launch platform like didn't have a good foundation and like was like tilting and settling, right? So there's there's certainly geotechnical engineering support for that structure. So there's a lot of expertise from different areas that civil engineers will be able to contribute to space exploration, just like we use expertise from other disciplines in our work. Civil engineering design is that when you're doing something that's a little bit more advanced, a little bit more cutting edge, or you're trying to sharpen the pencil to like get your design really nailed in, you might have an additional level of review or like an expert who's not, doesn't work for the same company, has an independent peer review. I imagine that would be like much more common as you're starting to do things on other planets, because there is no like local standard of practice.
There may not be many opportunities to build in space right now, but getting there requires an enormous amount of work, and much of it happens right here on Earth. Before we build cities on other worlds, we first have to build without certainty. And that's why, for engineers, the real challenge is deciding when the ground beneath you is finally safe enough to stand on.